Hello, everyone. Welcome to today's Meet the Test Data Manager Expert session. My name is Pamela Deason. I'm the head of application development product marketing here at Broadcom. For those of you not familiar with Test Data Manager, it allows users to create a subset of production data while masking all of the PII data elements. Or you can create synthesized test data, which doesn't require masking. Here with me today is Dr. Mahanti, the Test Data Manager product expert. He's going to be talking to us about scalable masking with Docker. Sasha, I'll turn it over to you.
Hello, everyone. Thank you so much, Pam. This is Satya Mohanty. I am a DevOps product specialist, and one of the products which I support is Test Data Manager. We will talk about how we can achieve scalable masking with Test Data Manager. We'll talk about a couple of options, how that is and can be done and can be deployed. The reason why data masking itself is an important topic is, of course, because we know that production data is potentially the highest quality data against which we would want our integration testing, system testing, user acceptance testing to go against. However, usage of production data, of course, comes with demerits, which is we risk the exposure of PII, PCI, and PHI data elements. Now, how do we address that? Is we take a two-step approach. Step one is we provide, as part of our test data manager suite, a product suite, we have a way in which we can identify which columns and which tables in your application will contain sensitive or PII data. And we can automatically identify the sensitive data and tag it to an appropriate tag, which will then enable the product or the TDM tool to assign a data masking algorithm or a data masking rule corresponding to the tags. Of course, there is a way that we can edit, we can modify, we can make it appropriate and make it customized to your organization and to your specific use case. But this two-step process with the tagging and the automatic discovery of PI elements, and the step two being doing the actual data masking. And while we are doing all of this, we also ensure that the data integrity and all of the relationships across the different tables and the different database types, that is maintained as well while the data masking is actually taking place. The reason why today, of course, masking has been around for a very long time, right? But then why are we talking about masking at an enterprise scale, or why do we talk about scalable masking, right? Because many of our customers, and these are some examples, with increasing data volumes and with the lower cost of storage, everyone now wants a large subset or potentially a fully representative production set of data in their lower environments to test against. That is great, but that comes with its own set of problems. For example, with a very large accounting customer, they had a need to mask 17 terabytes of data. A large financial institution, they needed to mask or obfuscate over 20 terabytes of data for some of their internal applications. One of the largest healthcare organizations, they needed to mask 1 billion rows, and in order to support DevOps and their automation, they had to accomplish that task in under less than 4 hours. That's not a lot for masking 1 billion rows. And one of the largest consulting organizations, they had to mask over 13 terabytes of data. So to mask this volume of data and to do it the traditional way, without any multi-threading, without any database optimization, without any scaling, which is a topic, of course, for today. Just for as an example, with a single thread of FTM, it took over 12 hours. For 50 million, 25 hours, and for 1 billion rows, it took over 50 hours. And of course, this is not a sustainable amount of time to accomplish these tasks to support the needs that we see from the industry right now. What can we do about it? What we have done from that perspective is we have got two options. One, we can implement a Docker-based scalable data masking, in which we will deploy manually scale out and manually scale back version, where your individual containers with Docker can have or can host multiple data masking FTM engines. This will allow that your masking engine to be distributed from your actual TDM engine. This will basically release a lot of memory, a lot of space, and a lot of computing power to your TDM engine running your maybe sensory data generation, or maybe running your data subsetting, or your find and reserve, or your self-service styles. So you can still do all of that on your central portal server, but distributing or doing a distributed implementation of your actual masking or your FTM engine will relieve some of that pressure on your main TDM server. And at the same time, by doing this scalable masking with Docker, you can scale out and, of course, scale back, as I mentioned, as and when needed, which means you can add masking engines to accomplish large tasks if you have to mask a lot of volume of data. And you can remove those masking engines once the task has been done. Now, what is the problem with that? Like, this is sounds good enough, right? We can mask large volumes of data. The challenge, of course, here is the manual nature of it, which is you will have to compute ahead of time how much or how many containers do you need. You will have to spin up those many containers, and then once the work is done, you have to scale them back. And of course, with infrastructure moving to the cloud, if you did not remember to scale your containers back, then that potentially causes additional costs which we do not want to incur. That is when, for a truly enterprise grade masking and a scalable masking rather, we will be able to provide an option too, which is what we recommend for an enterprise TDM implementation for scalable masking, which is by using Kubernetes. So the Kubernetes deployment of TDM comes with an automatic scale in and automatic scale out functionality, which means depending on how much information is there to mask, how many tables and how many rows of data are there, TDM will be able to scale out, add additional Kubernetes pods which can perform the masking, and within each of the pods we can have multiple FDM engines as well. So not only can we scale horizontally by adding number of pods, we can also within each of the pods have multiple FDM engines too. And all of that is intelligent, it is automated for both the scale out as well as the scale in. This is great, right? We don't have to compute how much space we need, we don't have to compute how many pods we need, how many FDM engines we need. All of that is done automatically. Of course, a key consideration here is we also deploy a optional throttling mechanism which lets you control how many pods, and within each pod how many FDM instance can actually be spun up. So all of that is deployed by using the auto scaling functionalities with Kubernetes. This automatic scaling has been achieved by using KEDA. KEDA is the Kubernetes based event driven autoscaler, and using KEDA we deploy this auto scale out. All right, so we will do a quick demo of what we just spoke about. And in today's demo, we will see that we have the Kubernetes pod, rather pods running TDM, and we will see one pod which is running the data masking engine. We will perform the data masking function on the TDM portal, and we will see how the pods are scaling up, scaling back down, and they will come back to the base. What we have done is we have set up a simple environment and a simple data model containing a few tables containing very large number of records. We have already done the profiling, and we have identified the PI data, and we have assigned data masking rules. Just to keep it all simple, we have applied a name masking, a hash LOV, and a country masking, again a hash LOV function. For the masking settings, we are keeping everything as default. We are only doing the large table split. We have enabled that and put that as a yes. And with that, we want to start the masking for our tables. But before that, I also want to show you that on our Linux console, we have, as you can see, one running masking pod. We have a few more which are basically inactive. And of course, we have the TDM Web and the OrientDB and the other pods, which will make TDM portal work anyway. As you see, we've got only one active masking pod. So when I start my masking, We want to see multiple masking pods spinning up and performing the masking task. And once that is completed, the masking is completed, we will see that spin back down and come back to this base state again. So with that, if we start the masking and I click on the disclaimer and I do confirm, we have kicked off the masking jobs now, and we will be able in real time how are the jobs progressing, how many rows are getting masked. And if we go back into our console and if we get the pods, as you can see, we have a much more number of masking pods now. We have got 1, 2, 3. We can quickly take a look at the count too. So we have got 14 pods now, including these inactive ones. We have 14 masking pods running. And if you can see here, that number has increased furthermore. So we have a number of masking pods running. If you go back into our TDM portal, you would see that the job has kicked off and it will continue to execute. As we were waiting for the masking job to complete, which as you can see took about 5.5 minutes, we can see that we were able to mask about 13 million records. And if we go back into the Linux console, if you remember, we had those 14 data masking pods, including the inactive ones which were running. If we do the same again to find the count, now it's back to the baseline, which was 6. And if you look at the pods too, so we just have that one active pod, which of course will be there because it is a masking service. But all apart from that have been now terminated, right? So we started off with a baseline with one masking pod. We started the masking service and we started the masking jobs to mask 13 million records. We saw that the pod scaled out automatically to 14. And once the masking was completed for the 13 million records, we again scaled back in and we are back to 6. And all of this was completely automatic, completely automated. There is no manual intervention. So this is a very powerful feature for a enterprise deployment that you don't have to be aware of when you have to scale up the pods, when you have to scale them down. So all of that is automatically done by using this solution on this Kubernetes deployment of TDM.
Thank you, Sasha, for being our expert today. You've been quite informative, and I look forward to hearing from you on other test data manager topics.
Absolutely. Thank you, Pam.